Okay, today we're doing lesson 2.1. This time, if you notice that we are solving quadratic equations, before we were factoring, we used completing the square, all those to factor, but we never solved. So what I want you to think about is this really quick. If A times B equals 0, if you think about it, I have two numbers that equal 0. Then A has to be 0 or B has to be 0. One of those two have to be 0. They both, that's how it works for this. This is called the principle of zero products, if you must know. But anyway, so using that idea, when we have this idea, when we factor, this allows us to set things equal 0, because these are factors. One of those factors has to be a 0. So the first thing we're going to do when we talk about solving by factoring, that's the first one we'll do, you want to make sure that you are, that the equation is set equal to 0. Must be set equal to 0 before factoring. So if I think about that way, I'm going to look at this first one, letter A, and I'm going to factor. That's already equal to 0. So all I need to do, two parentheses. Since this is a minus and a plus, I know I'm going to have a minus and a minus, okay? Well, A here is only 1, so I have X and an X. I know it's a minus and a minus, so I can put those there. So now I got to think of the factors of 6. So 2 and 3, 6 and 1. We usually use the closest one. If I put 2 and 3 here, multiply it together, I do get this -5. So this equals 0. Okay, so always check. And then now I'm going to use this principle up here. When I want to solve, because it's telling me to solve, there's an equal sign. I'm going to do x minus 2 equals 0, x minus 3 equals 0. Solving for x, I added 2 here. I won't show this every time, but I wanted to, for a few times, make sure we're good with that. So I get x equals a 2. And I get x equals 3. I want you to realize that we are doing a quadratic, a parabola, okay? That's just telling me, where does this graph cross on the x-axis? These are x-intercepts. So if these are, I'm telling you, you cross at a 2 and a 3, and that graph goes like this. So that's what these are happening. We're not graphing them, we're just finding the solutions of those zeros, okay? The x-intercepts. Okay, letter B. This is all by factoring. Everything that we've done before we're going to do. The first thing we want to do is set it equal to 0. That 26p is here. So we're going to move that over. So what I want to do is subtract 26p from this side. I'm going to write over here. So what I have left is 4p squared. I'm going to write the negative 26p first between the 40 and the 4p squared. And then 26p minus 26p is 0. Okay, so now it's set equals 0. Next step. Now, other one we didn't have to factor. We're going to look at A. A is 4. So we need to factor out, or excuse me, A is 4. We have B is 26, and we have 40. So they all have a GCF. So the GCF of all of those is 2. So I have 2. So please remember that you're dividing by a 2 every time, so that you realize what you have left over and don't make a silly mistake. Minus 13p and equals 20 equals 0. Okay, so now I have to factor this. Again, I have a minus and a plus inside that parentheses, so I will be doing a negative and a negative, just like the last problem. Okay, so 2 is out here, don't forget 2. I have 2 parentheses equals 0. And I'm going to factor. So 2 has only got only has one set of factors, 1 and 2. So it doesn't matter. I can put a 2p here and a p here, or I can switch them up. Now I got to look at 20. My factors of 20 are 1 and 20, 2 and 10, 5 and 4. Usually we take the smallest 2 in between. So we do 5 and 4. The 5 has to go in this, the 5 has to go in the other one, because you can have common factors. So 5 has to be here, 4 here. And I want a negative 13. So they both have to be a minus, so we want to see if we come up with a negative 13. So 2 times a negative 4 is a negative 8p. Negative 5 times p is negative 5p. So yes, I get a negative 13p. So now that I have this, I'm going to do the next step, and I'm solving. So I'm going to set them equal to 0. So 2 equals 0. Everything gets set equal to 0. Okay? So, but this first one doesn't make any sense. 2 does not equal 0. The reason I want to make sure you show that, because sometimes this 2 is a variable or has a variable attached to the 2. If it has a variable, it's got to set equal 0, and you can still solve for it. But I just want you to practice that so we don't forget to do everything. Okay, so here, let's solve for p. If I add 5, I get 2p equals 5. And then if I divide by 2, I get a 2. Here I'm going to add 4. So p equals 4, and p equals 5 halves. Okay, let's look at this next one. This is a difference of squares. So difference of squares are rules and everything. So we know that the square root of 16 is 4. This is going to be an m. And square root of that is 5. So we have 2 of those, and our signs are the opposite. So put a plus and a minus. It's set equal to 0. Again, solve for m this time, by setting these two equal to 0. Subtract 5. 4m equals a negative 5. Divide by 4. M equals negative 5/4. This one over here will be m equals 5/4. A little bit too big. Okay, so let's look at this last one for factoring for this group. Oops, didn't mean to do that. Well, let me erase. There we go. Okay, so now let's look at this. I still have to follow my factoring rule, so I'm going to factor out a GCF, which is x squared. Okay, so I'll give myself room. So x squared. So I'm dividing this by an x squared, dividing this by x squared. So we have 6x minus 1 equals 0. So now set these equal to 0. So here we have a square. To undo a square, we take the square root. So we're going to take the square root of this, square root of that. Square root of x squared is just an x. Square root of 0 is just a 0. Solve for x over here. Add 1 to both sides. 6x equals 1. X equals 1/6. There's an answer. And there's an answer. Now, the next one we're going to do is a two different ways how we're going to solve for this quadratic. First, they're going to do by factoring, then we'll do solve without factoring, okay? So when we do solving without factoring, we want to make sure that we want to do this other side to understand what our answers should be so that we're not leaving an answer out. So if we do the way we've been doing earlier, I have to take 16 to the other side. I have x squared minus 16 equals 0. So now this is a difference of squares. So I have x minus 4 times x plus 4 equals 0. And now I'm going to set them both equal to 0. And then x minus 4 equals 0. So we get x equals 4, negative 4 here, and we get x equals 4. okay? Now, these are two of the same exact equations. They are not different, okay? They're both the same, so they look the same, but this time we're going to solve without factoring. So kind of using the idea I did up here in D, where I took the square root. Okay, so since I have x squared here, and 16, I'm just going to take the square root of both sides. So I take the square root of x squared, I take the square root of 16. X squared is equal to just x. Square root of x squared is equal to x. And then 16, though, we know square root of 16 is 4, but we also have another one. Think about negative numbers. Sometimes we don't think about negative numbers, but negative 4 times negative 4 is a positive 16. And if I just put 4, we know that number 1 and number 2 are the same equation. I just can't, what happened to this negative here? Where'd it go? So this is where you get the plus or minus 4, okay? Again, it's the same thing, two solutions here, okay? All right, so let's try the next part. We're going to use the non-factoring method to solve the following. Now, if you noticed up here, number 2, it was something squared equals a number, okay? So I need something squared equals a number. It doesn't matter that I have an x minus 2. The whole thing is in parentheses, so it's all being squared. So now, since I have that, I can do what I did earlier, and I will take the square root of both sides. Okay, so x minus 2, quantity squared, is just x minus 2. Square root of 16, though, is plus or minus 4. Now, remember, we have two answers, two solutions. This is a quadratic. It, most of the time, doesn't always, crosses the x-axis or in two places. So we're just going to solve for different ways you can do this. You can set this up as two equations. You can move the 2 over. So since I want to make sure we understand there are two equations. So my first equation is x minus 2, so I leave that, equals, and I'm just going to do the positive 4. And my second equation is going to be x minus 2 equals my negative 4. Okay? That's the difference there. Solve for x. So x equals 6. Again, solve for x. X equals negative 2. For problem 2, okay, same thing. Something squared equals a number. Doesn't matter what the number is, it equals a number. Doesn't have to be a perfect number, just a number. So the first thing I'm going to do is take the square root of both sides. So what's left here is x plus 1. Over here, though, I have plus or minus the square root of 3. Okay? Now solve for x. We're going to move the 1 over. The 1 should be written in front. You need to write it in front. That's how we read things mathematically. Things will be written in this form that you see, and I want you to understand that you will see this form, and this is what it looks like when you read books or any type of math book or stuff like that. And this is best practice, especially when it comes to doing more that we'll be doing with imaginary numbers. This is still two solutions real quick. I want to make sure everybody understands that. Oops, let me write the two solutions. So we have x plus the square root of 3 and x negative 1 minus the square root of 3. Still the same thing as this. I will take this, but understand, I will take this one. It's fine. As long as you understand there are two solutions. Now, this is not, square root of 3 is not a perfect square, so this is actually a decimal answer where it crosses the x-axis. But you just have to figure out, you would have to use a calculator to find what it is. It won't ever be exact. This is exact this way. So make sure that you are writing it with the square root. Notice over here, I came up with this. That doesn't mean, with that right there, since I can add, like I said, like I showed, 2 to both sides and so forth, I can find a number. If there's no radical, then you must do it this way. So radical, you can leave it this direction. Okay, last part of the page is simplifying radicals. And if you notice, this is not equal signs. This is just taking the square root of something. We want to do this to see how, to make sure that we understand all the different rules. Just like fractions, just like anything else in math, you have to clean it up, you have to simplify when you're supposed to, you have to reduce fractions, and that's what we're going to have to do with radicals. So the first thing we're going to look at, if I take the square root of 169, which is a perfect square, that's just 13. For these, I don't do plus or minus because I'm not trying to find a solution, as in what x equals. I'm not trying to find what crosses the x-axis, the intercepts. I am just wanting to know what that is. So what we're going to do with the next one is this is not a perfect square. So what you want to do, always try to find the largest perfect square. And we're doing squares. You can do radicals, but largest perfects for us, we're doing squares. Remember, squares are, oops, wrong. One's, 4. Perfect squares. One, let me write over there. So perfect squares, remember, they're 1, 4, 9, 16, 25, etc. You want to think about dividing these with this. Well, this is, so what I see, the largest perfect square in here is 9. Now, how you were how you were taught to do this might be slightly different than how I'm going to show it, but you can do the way that you learned. There's nothing wrong with that. If you have any questions on why we're not getting the same thing, just let me know. So what I think about, the square root of 18 can be broken down into 9 times 2. Well, one thing about, and I won't do this every time, this step, but I want to make sure that you understand one thing about our rules. We're allowed to break this up to into 2 separate square root signs so that we can see what I'm actually allowed to take square root. Well, the square root of 9 is 3. So that's going to go up here. And I don't know the square root of 2 without a calculator, so we're going to leave it like this. This is an exact answer. This is the way you're supposed to leave it. Okay. The next one, we have square root of 24. Now this one, a lot different. Just find that perfect one. Sometimes we just go for what we know are the factors. If you need a list of factors, you can. But I know that 4 times 6, this is the only perfect square in there. Okay. So I know that's going to equal this. So I'm going to take the square root of 4 times the square root of 6. Square root of 4 is just 2. And then multiply that answer by the square root of 6. The last one, and I'm going to do it just slightly different. The last one's a little bit different, as that if you don't find the largest perfect square, you just have to take an extra step. So I'm not going to find the largest. I'm going to do square root of 9 times the square root of 8. Okay? Well, square root of 9 is 3. But as we've seen, or you'll do this a lot, 8's got a perfect square in it. Square root of 8 is the same as square root of 4 times 2. Okay, so if I take and break that up, I get 4, square root of 4 is 2, and this comes down, so square root of 8 is equal to 2 times the square root of 2. So when you do this way, you have to remember, this is multiplication. So I have 3 times 2 times the square root of 2. I'm multiplying these two together. I'm going to do it in parentheses. Well, 3 times 2 is 6. So my final answer is 6 times the square root of 2. Now, the largest perfect square in 72, I just want to look real quick, is 36. 36 times 2 gives you 72. So then you would break it up as square root of 36 times the square root of 2. And if you notice, that's exactly what I have up here. So if you don't find the largest perfect square, you just take extra step. You just have to make sure every time you reduce that radical or simplify the radical that there is all the perfect squares are gone. All right, so the next one, this is a fraction. I want to write it like we would, we're allowed to do. When we have fractions, just like multiplication, we can separate them into the numerator and the denominator. Now, if you see a perfect square, I don't expect you to do this step, but I want you to see that square root of 100 is 10 over 9. Okay, that's our solution. And this is going to help us with letter F. Now, letter F. This is not a perfect square underneath here at all. If I separate them, I'm going to do it over here. I'm going to split the square root of 3 over the square root of 5. Okay, these two are not perfect squares. So again, with that square root of 5 in the denominator, we do not like in mathematics with fractions, you have to simplify the fraction. We always reduce, we don't have certain things that we do in math we have to take care of. Like we clean it up. We don't, leave x minus 0 or anything like that. So the same thing is happening with the square root. You're not allowed to have a square root in the denominator, okay? So what we do is we get rid of it, and the way we get rid of it, it's called rationalize the denominator. So first thing is, I'm a little note, can't have a radical in the denominator. We will need to rationalize to okay, so can't have a square root or a radical in the denominator. We will need to rationalize the denominator to get rid of that square root. So rationalizing, that means I'm going to look at what's inside here only. So look what's inside the radical on the bottom, and I'm going to multiply by exactly what I have. So on the bottom, I have the square root of 5. So I have to multiply this by the square root of 5, and what you do to the bottom, you have to do the top. That's called rationalizing. So when you get done, though, you should not have a radical anymore, okay? So in the numerator is 3 times 5, so I'm going to wind up with the square root of 15. In the denominator, though, what's 5 times 5 is the square root of 25. Well, square root of 25 is a perfect square, so I have to take square root of 25, and this is 5. And so now I've rationalized the denominator. From this step to this step, you don't have to write that we understand. All you're going to do is you want this out of the radical, and that's the way you do it, okay?